Hey everyone, in this video I'll walk you through how I built a portable solar power station using a Harbor Freight hand truck, a SunGoldPower 5000 watt all-in-one inverter, and a 48 volt Eco-Worthy lithium iron phosphate server rack battery. The reason for this project is to provide electricity to a small workshop that I'm in the process of building. As you already know, getting an electrician to run electric to a new building will cost a lot of money. So I figured this is a good opportunity to get into solar. And YouTube solar channels make building these things look very easy. I've never messed with solar before. I'm not an electrician, so don't do what I do. I basically watch videos from guys like Will Prowse and Lithium Solar to learn. This video is from the perspective of a guy who had a requirement for electricity, and this may be a solution for it. This is how I did it. It's probably not the best way. Let's dive into the build. The three main components for this power station are, first, the Eco-Worthy 48 volt, 100 amp hour lithium iron phosphate server rack battery. It's got a BMS over 6,000 cycles, so it lasts a long time and is designed to deliver a lot of power for off-grid use. Next, the SunGoldPower 5000 watt 48 volt all-in-one inverter. Model is SPH5048P. It's an inverter, a charger, and a solar controller in one unit. It can handle grid, battery, solar inputs, and outputs pure sine wave AC power. So it's good for sensitive equipment like computers and TVs. And finally, to make this thing mobile, I'm using a Harbor Freight heavy-duty hand truck. It's inexpensive, strong, and easy to customize into a rolling power station frame. Before I started touching anything, I made sure everything was off, the batteries and inverter. To start the build, I mounted the battery securely to the bottom plate of the cart using heavy-duty zip ties, a cheap strap, and a rubber mat. Glad the battery came with handles. It weighs around 100 pounds. Then I mounted the inverter to the cart. I used these metal bed frame tubes found in my garage. I cut them to size and drilled some holes. You can mount this a million different ways. Some people use plywood, C-channel, zip ties, but I always try to use any spare materials I have lying around. Feels solid. I change these for machine screws or bolts eventually to get rid of these sharp points. For the wiring between the battery and the inverter, I created custom battery cables using 2 AWG wire from Home Depot. They only have black cable, so I use red heat shrink and electrical tape for the positive cable. The lugs were purchased from Amazon. Made for the 2 AWG wire. They're made of pure copper. They're 5/16 hole, which fit the battery terminal bolts perfectly. Also came with black and red heat shrink. I crimped the lugs myself using the TEMCo hammer lug crimper tool. It's a simple tool, inexpensive, but it makes strong, secure crimps if you do it right. Hit it with a hammer until it feels solid. I also use heat shrink on the cable terminals and zip ties to secure all the wiring for protection and a clean look. To be able to use this thing, we'll need some outlets. I opted to connect this 6-outlet 20-amp power strip. This is temporary as I have future plans to add circuit breakers to make use of the 40 amps this inverter puts out. Inserting these small cables into the terminals was annoying, but I later found that it's easier using needle nose pliers. I don't have solar panels yet, so I'm attaching this power cord into the AC input. This will allow me to charge the battery using household electricity from the grid. You can buy these cords at Amazon or Home Depot. I recommend getting one that is 14 AWG or thicker. Mine is 12. I inserted this one just like the black cord with the outlets. Have to make sure these terminal screws are very tight. I also installed the battery cables on the inverter. The bolts use a 10mm socket. Lastly, I had to attach the battery cables to the battery itself. I double checked that the battery was off, also checked the voltage using a multimeter before touching anything. Also double checked that all connections were tight. I also bought these silly high voltage gloves to use for making the battery connections. They say 48 volts can hurt you bad, so I wanted to take precautions. It's impossible to work with these, so I took them off in about a minute. It's crazy that I'm not afraid of welding electricity, but this is different somehow. I just double checked all the switches were off, the battery, breaker, BMS, inverter. The battery terminal bolts require a 13mm socket. Once everything was wired up, I did a basic function test. I powered it on, battery breaker first, the round BMS button on the battery, black switch on the inverter. It took a few seconds and the inverter powered up cleanly. Before I do any testing, I changed a few of the settings. Setting 07, which is max charging current, I changed it to 15 amps since I'll be using 15 amp household current to charge the system until I get my solar panels. When I get my solar panels, I'll change this setting. Next setting is setting 08, which is for battery type. The default setting is for gel batteries, but my battery is what they call a lithium iron phosphate type. So I changed this to LFP16. I first changed this setting to user, but it wouldn't give me the battery charge percentage on the screen. That's why I changed it to LFP16, and that seems to work. The next two settings are to allow communication between the inverter and the battery. The SunGoldPower inverter came with this Ethernet cable. I connected it to the RS485 ports on the battery and inverter. Then I changed the settings for items 32 and 33. For setting 32, I chose 485 as the setting. For setting 33, I chose PYL. There are a lot of settings on this thing, but these got me started. I have to do more research to get the correct settings when I connect this to solar. After making those changes in the settings, we can now see the state of charge of the battery in percentage. I connected the unit to the wall outlet and charged it overnight. Next day, I wanted to test my 20-gallon air compressor. This compressor only works with one outlet in my entire house. It trips all the others. Not sure what the deal is with that. As you can see, this unit was unable to run the compressor in its current configuration. Maybe when I set up a legitimate 20 amp circuit, it will do it, but who knows. I tried twice, but the system shut itself off. It recovered on its own, which is good. Next, I tried this reciprocating saw. It uses 10 amps at 120 volts AC. It ran just fine. Here's the inverter display while the saw was running. No issues. This thing can also work as a UPS, so I tested that. I plugged a fan into the inverter outlet, plugged the inverter to a house outlet. The system is now in pass-through mode. Pass-through mode means it's powering your fan using the house or grid electricity. With the fan running, I unplugged the inverter from the house outlet and it automatically switched to battery with no interruption to the fan. This would work great for a refrigerator or computer equipment. I'll be connecting this to my 2600 watt solar array soon. I'm still waiting for the panels, but that will be another video. From what I've seen, this system is scalable because you could add more inverters, you could add more batteries, and it's way more affordable than many of the all-in-one solar generators on the market. So there you have it, a DIY solar power station that anybody could build. The ultimate goal of this hand truck is to provide electricity to my small workshop and my chicken coop, ventilation fans, and the lights, as well as to provide my RV with some electricity while it's in storage. And of course, the occasional hurricane power outages we get here in Florida. So that's it. Thank you for watching my video. If you found this helpful, hit the like button, subscribe for more DIY projects, and drop a comment with any suggestions or any questions.